Howdy, my name is Kayla Martinez and I will be presenting our semester project titled Analysis of Drainage Patterns and Potential Flooding Issues Between Evans Library and the Liberal Arts Building. This presentation provides a summary of the final class project carried out by myself and my fellow students. Kayla Martinez, Mei-Ling Chow, Anna Bonsinski, Jack Howell, James Wilde, and Nathan Leake. This project focused on examining the impact of excessive rainfall and drainage system failure on the Texas A&M campus. Various data was collected from online sources in the field to help model these flooding events. After analyzing the data, a report was prepared to convey the findings and a proposed solution to any discovered risk. The primary dataset was a collection of key drainage points collected using a Garmin GPS device. After taking these points, Nathan collected the relevant data into a CSV file which was shared across the team. The points were then imported into Google Earth and to continue the study. These are a bit hard to make out, but here you can see the GPS points displayed on a screenshot taken from Google Earth. The white dots are our points. Although not clearly visible on this map, we are able to import local area elevation readings into Google Earth from an online GIS data center. These points are located here and here. And here is a large-scale contour map from the USGS website. And lastly, here is an image of the combined points overlaid on the elevation map. Ultimately, the findings indicate that the area is indeed uneven and could potentially fill with water like a basin. This could occur as a result of failure of several key drainage points in this area. If left unchecked, rising water could even enter adjacent buildings, causing unknown degrees of water damage. The study could be extended with further data and analysis to determine exactly how much water could be expected to fill the area before overflowing down towards the administration building. The most appropriate tools for further statistical analysis could be ANOVA, which is the analysis of variance, to compare the flooding across all the known days with very high precipitation, and also a paired t-test could be used to find any changes in local topography over time. Results drawn show water initially pooling between Evans Library and the Glasscock building, and eventually overflowing towards the pavement between Glasscock and the Liberal Arts building. Various flower beds and uneven concrete surfaces in the area could also hold varying amounts of standing water. In a worst-case scenario, drainage grates bordering the sidewalk could become obstructed, leading to water rapidly accumulating outside the Liberal Arts building. This water would eventually rise high enough to enter adjacent buildings, causing water and debris damage, as well as potential mold and contamination. In conclusion, it is important to have a proper understanding of campus topography in this area and how changes in drainage patterns could impact the system, as well as which buildings could be affected and how to best mitigate the risks. In review, the conclusions of the study are relatively strong, but it is important to point out potential weak spots and steps that could be further improved. For example, more GPS points could have been taken using high precision equipment and techniques such as RTK or post-processing. If not for campus policy, flying a drone to build a 3D map of this area would also be useful for the continuation of this project. This project is important because it provides insight into a risk to the Texas A&M campus. Texas A&M University is an important site to thousands of students, professors, research faculty, and individuals, and as such should be carefully maintained and kept in full working order as much as possible. In order to mitigate this identified risk, the team has proposed careful monitoring and modeling of the area, and possibly the construction of a secondary load-bearing drainage system. And that about wraps up the presentation. Here are 3 of our primary data sources used. For more sources, please refer to our team or individual report documents. Thank you and have a great day.